today we are going to look at application problems with radicals and rational exponents. So remember that radicals and rational exponents can be rewritten in reverse order. So if I say x to the 1/2, that's really the square root of x. X to the 1/3 is really the cube root of x. So today we're going to look at some application problems involving solving radical equations. So let's look at this first one. It says that Helena drops a ball from 25 feet above a lake. The formula T is equal to 1/4 times 25 minus h describes the time T in seconds that the ball is h feet above the water. So we want to know how many feet above the water will the ball be after 1 second. So we know that T is time, and we know that h is the height. So if we want to know how many feet above the water, we're looking for h. And they're telling us that time is 1 second. So we're going to take that equation, T equals 1/4 times the square root of 25 minus h, and we're actually going to solve for h given that T is 1. So let's go ahead and replace T with 1. Now that I have this, I'm solving just like we did last class. I need to get the square root by itself on one side of the equal sign. So the first thing I want to do is I want to multiply by the reciprocal to get rid of that 1/4. So I'm going to end up with 4 is equal to the square root of 25 minus h. Now my square root is by itself. I'm going to go ahead and square both sides in order to get rid of that square root. So 16 is equal to 25 minus h. Now I'm going to solve for h. I'm going to subtract 25 from both sides. So I'm going to get negative 9 equals a negative h. But I can't leave that negative on the h, so I'm going to go ahead and divide by a negative 1. So I get 9 is equal to h, so it is 9 feet. Okay? Alright, let's look at this next one. This next one says the speed of a vehicle before the brakes were applied can be estimated by the length of the skid marks left on the road. On wet concrete, the speed v in miles per hour can be estimated by the formula v is equal to 2 times the square root of 4.3 times fd, where f is the coefficient of friction and d is the length of the skid marks. So calculate the length of the skid mark if the velocity is 45 miles per hour and the coefficient of friction is 0.7. So this is going to go in for f, and we're told that our speed is 45 miles per hour. So that's going to go in for v. So I'm going to take that equation, and I'm going to plug in what I know. We're told that our velocity is 45, and we're also told that our coefficient of friction is 0.7. So I am going to try to solve for d. First thing I'm going to do is I'm going to go ahead and divide both sides by 2. So I'm going to get 22.5 is equal to, I'm going to go ahead and do 4.3 times 0.7. I'm going to get 3.01d underneath. Now my radical is by itself on one side of the equal sign, which means I can square both sides to get rid of it. So 22.5 squared is going to give me 506.25 equals 3.01d. But I still need to get d by itself, so I'm going to go ahead and divide by 3.01. And I'm going to end up with 168.2, and that is feet for the length of the skid marks. Okay? Alright, on the inside, we have the formula B is equal to 0.01 m to the 2/3, where B is the animal's approximate brain mass, and m is the body mass. Alright, so a moose has a body mass of 512. Calculate the brain mass of the moose. So brain mass is B. And this time we're told that the body mass is 512, so I'm going to go ahead and plug that in. So I'm going to raise 512 to the 2/3. Which gives me 64. And then I need to multiply 64 times 0.01. So brain mass is going to be 0.64. Okay? A cat has a brain mass of 0.029. Calculate the body mass. So now we're going to go the opposite direction. This time we have the brain mass, we want the body mass. So I'm going to go ahead and put 0.29, 0.1 m to the 2/3. So the first thing I'm going to do is divide by the 0.01. So 0.029 divided by 0.01 gives me 2.9 equals m to the 2/3. Now remember, when we're solving rational exponent equations, we raise it to the reciprocal, so to the 3/2 on both sides. So I'm going to get 2.9 to the 3/2, which is basically saying take the square root of 2.9 and then cube it. So we're going to get 3/2. So I get 4.93 is equal to the body mass. Now we have a rhinoceros. We have a rhinoceros that has a brain mass of 0.788. So my brain mass, remember, is B, so 0.788, and I want to find the approximate body mass. So first thing I'm going to do is divide by that 0.01, and I get 78.8 equals m to the 2/3. Okay, so my base raised to the exponent, I'm going to raise it to the reciprocal. So I'm going to take the square root of 78.8, and then I'm going to cube that answer. So I get 699.5 is the body mass. Oh, not B. M is the body mass of the rhinoceros. Okay. All right, 4 through 6 is a review of what we did last class. However, we have to check the solutions when we are solving these radical equations to make sure that we did not create an extra answer, especially on 5 and 6, because we are going to be foiling. All right, so right here, I need to get the x minus 6 to the 4/3 by itself. So the first thing I'm going to do is multiply by that 5/1 to get rid of that 1/5 right there. So I'm going to get x minus 6 to the 4/3 is equal to 125 times 5, which is 625. Once I have the base raised to the fraction by itself, I raise it to the reciprocal. X minus 6 is equal to 625 to the 3/4. And so 625 to the 3/4 is saying the 4th root of 625 cubed, which is going to give me 125. So if I came over here, I'd say 625 Divide by 5 is 125. Divide that by 5 is going to give me 25. Divide by 5 gives me 5. So if I'm looking at the 4th root of 625, I need 4 of them. So that brings out a 5. And then that 5 is still cubed, which is what gives me the 125. Then from here, I'm going to add 6. So x is equal to 131. Okay? All right, on number 5. This is a little different. I'm trying to get my radical by itself on one side of the equal sign, and then I'm going to square both sides. However, I have an x on the other side. My x isn't just inside the square root. When we square both sides on these type of problems, you have to check your solutions because the likelihood of one of them not working is extremely high. So we're going to square both sides. On the left-hand side, it just gets rid of that radical. But guys, when we say x minus 3 squared, we're really saying x minus 3 times x minus 3, which means I have to actually multiply that out. X squared minus 6x plus 9. Now get everything onto one side. I'm going to move everything to the right-hand side since I have a squared term. So I'm going to add the 2x. And then I'm going to subtract the 30. Now remember, we can factor quadratic, so I'm looking for what multiplies to give me 21 and subtracts to give me 4. Well, if I list my factors of 21, 3 and 7 subtract to give me 4. Because my middle term is negative, the larger factor will carry the negative. So I get x plus 3 equals 0. And x minus 7 equals 0. So negative 3 and 7. Now, we have to go back and check these to make sure they work. Start with your negative because it's probably the one that's not going to work. So I'm going to go back to my original equation. So negative 2 times negative 3 plus 20. Is that equal to negative 3 minus 3? So over here, I'm going to get negative 6, positive 6 plus 20. Is that equal to negative 6? Well, I can stop right there, because can my square root be equal to a negative? Oh, and that is a 30. Sorry, guys. That's a 30. Okay? So I would end up with the square root of 36, but we know that that cannot be a negative, which means negative 3 does not work. Go back and try 7. So negative 2 times 7 plus 30, is that 7 minus 3? So negative 2 times 7 is going to be a negative 14. So negative 14 plus 30 is going to give me 16. So is 16 equal to 4? Yes. So the 7 works. The 7 is fine. Okay? Alright, let's try it again on number 6. So again, I have my radical by itself on one side, and then I have the x plus 1 on the other side. There's an x on the right-hand side, so when I square this, it's possible that I'm creating an extra answer. So when I square the left-hand side, I just get 7x plus 15. But x plus 1 squared is really x plus 1 times x plus 1. So when I multiply it out, x squared plus 2x plus 1. Let's get everything onto one side again. Again, I want to keep everything onto the side with the x squared so that I can factor. So I'm going to go ahead and subtract 7x. And then I'm going to subtract the 15. So I'm looking for my factors of 14 that subtract to give me 5. So 1 and 14, 2 and 7, 2 and 7. Again, my middle term is negative, which means my larger term will keep that negative. So I have x plus 2 equals 0 and x minus 7 equals 0. So negative 2 and 7. Alright, so again, we have to come up here and check them. Start with a negative, because that's probably the one that doesn't work. So 7 times negative 2 plus 15, is that equal to negative 2 plus 1? So on the left-hand side, I'm going to get negative 14 plus 15. Is that equal to a negative 1? Well, can my square root be equal to a negative? No. So I know negative 2 doesn't work. Now let's try 7. So I have 7 times 7 plus 15. Is that equal to 7 plus 1? So I'm going to get 49 plus 15, which is 64. So is 64, the square root of 64 8? Yes. So 7 works, but negative 2 does not. So anytime you have to square both sides and you have an x on this side without the radical, you 100% need to check these solutions, because one of them will probably not work. You have that extraneous solution. All right.